Okay, so I have my TinkerCAD circuit here of the Find and Push project I'm working on. So um, I have here the two motors, the two DC motors here connected to the outputs of the H bridge here. I have my LED here connected to pin D12 on the Arduino Uno. I have the ultrasonic distance sensor here connected to the VCC is connected up to the 5 volts of the Arduino Uno. I have the trigger pin here connected to pin D11 on the Arduino, and the echo pin here is connected to D10. Then I have the ultrasonic distance sensor connected to ground here. I have the bottom bus here as 3.3 volts coming from the Arduino, and I have the V-in connected up to the positive bus here, or the top bus, which is being fed with this 6-volt battery pack. And it's also going into the H bridge here. So in the 3.3 volts bus here, it's going to be using the LED and the TCRT 5000. So the TCRT 5000 set is connected to A0, and basically I'm using a digital read function for this slide switch here. So it's going to be a value of 1 or 0, so high or low, which is going to represent black or white on my physical circuit. I don't actually, TinkerCAD doesn't have a TCRT 5000 color sensor, so I'm using a slide switch to just represent that as a digital write. So it's going to be either on the left side or the right side, it's going to be black or white, which is also 1 or 0. So I have here in my code, I have my hashtag defines. I have I'm going to be using these for when I'm transferring the TinkerCAD code over to my physical code, which is on the Arduino IDE. I have the two variables here, duration and centimeters, cm. So duration here is set as long, and it is equal to 0, and then centimeter here is set as an integer value, and it's equal to 0. In my void setup here, I have a serial begin here, which is going to transmit out 9600 bits per second for the serial monitor. I have all my pin modes here, so I have all of my motors that I need, the motor speed for the motor B and A, and then I have the outputs all pin moded, and then I have the ultrasonic distance sensor pins here, the trigger pin and the echo pin. The echo pin is an input and the trigger pin is an output. And then I have my red LED as an output and infrared as an input. So that's the TCRT 5000. I have two functions here, the analog write, which is going to give a value of 255 to both of the motors here, which is going to be a max value of RPM. So it's going to be 10,000 RPM. It's going to be around that anyway. So this is basically the beginning of the void loop. So I have set state as an integer value, and it's equal to 0. So initially when this program is started, state is going to be equal to 0. I have here black and white variable is set as an integer value, and I have black white here equal to digital read infrared. So that's what I was saying earlier. It's reading a digital value instead of an analog value. So it's reading a 1 or 0. I have here digital write to the trigger pin, low and then high and then low. So that's basically just sending out a square wave pulse, and it's going to bounce off whatever object is in front of it. It's going to send back a signal into the echo pin, which is right here. So I have I'm using the pulse in for the echo pin, and it's constantly set as high, and that's going to be equal to the duration, which I'm going to use for the centimeters here in the formula here. So centimeters is equal to the duration, which is the time that it takes for the signal to be sent out and then taken into the echo pin. I'm going to multiply that by 0.0343 and then divide it by 2. And that's going to give me a centimeter value, which I can use in my code now. So this is basically where the void loop actually begins. So I have here an if statement that says if black and white is equal to 1, which is black on my physical circuit. So if it's equal to 1, rotate and delay the rotate for 500 milliseconds. So it's basically just going to be, this is just going to be checking for the black tape, and once it sees it, it's going to rotate the robot so it stays inside the arena. And I have an if statement here that says if state is equal to 0, which it is. The whole program began as equal to 0, state is equal to 0. So if state is equal to 0, then search. So basically, I've set search as a function there that I've set up here, down here. So this is void search here, and basically analog writes a value of 180 to motor B. So the motor B value is going to be slightly slower than the motor A value because the motor A value is still going to be at 255 and the motor B is going to be at 180. So that's basically just going to allow the robot to drive forward, but it's going to slightly be turning to a bit. So it's going to have a wide radius where it's going to be driving. So it's going to be driving in a big circle, basically just searching the area. And yeah, I have the LED set as low there and that as well. So basically, this is exactly what's going to be happening as soon as the program begins. So it's going to just search the area. It's going to, once it's on the white paper, it's going to drive around in a huge circle, kind of a straight line, but just a bit off, in order for it to actually search the area. And the if statement here is going to be constantly being checked as well. It's going to be saying if the color sensor detects the black tape at the edges of the arena, then rotate just so it stays inside the arena, and then continue to search. And while it's searching, it's going to be asking this if statement here. It's going to be asking if centimeters is smaller than 30 centimeters. So if this ultrasonic distance sensor is seeing an object that's below 30 centimeters, then it's going to do this. So it's going to say state is equal to 1. So initially state was equal to 0, but now state is equal to 1 after it sees this object. And then, so that basically this whole code here is going to be forgotten about. We're going to move on to state equals 2, or state equals 1. So in the function state is equal to 1, it says if state is equal to 1, attack. So it's going to, in theory, it's going to be searching the area. It's going to see an object, and then it's going to just drive forward. So the attack function is below here. It says drive forward. So motor A1 is high, motor A2 is low, motor B1 is high, and motor B2 is low. So basically that's just telling the motors to drive forward. And it resets the analog right motor B speed as 255. So basically motor A speed and motor B speed are now going to be 255, which is going to allow the robot to just drive forward, which is the attack function. So now it's in attack. And while it's attacking, it's going to be searching this code here, which is saying if black and white is equal to 1. So if the sensor sees 1, which is the black tape at the edges, state is equal to 2. And once state is equal to 2, it's going to forget about all this then. This is all going to be forgotten about now. And it's going to be in this state here. So if state is equal to 2, then stop. And my function here for stop is, it's going to start off with digital write, motor A1 high, motor A2 low, motor B1 low, and motor B2 high. So this is going to actually reverse the motors. And it's going to delay that for 1000 milliseconds. And then it's going to completely stop. It sets all the motors to low, and it sets the motor speeds to 0. And it delays that for 10,000 milliseconds then. So basically it's going to reverse for 1000 milliseconds and then stop completely for 10,000 milliseconds. So I'll show how this works now. Okay, so the ultrasonic distance sensor is seeing the object, but it's actually 66 centimeters away, so it's not actually interfering with anything. It's too far away for the loop to actually do anything about it. So basically, as you can see here, it says minus 10,700 RPM. So basically, that motor is driving forward, and the motor down here is at minus 7,500 RPM. So as I said earlier, it's in the search at the moment. It's searching. So the motor B is actually slower than motor A, so it's basically doing a wide turn. And I can pretend here that the ultrasonic distance sensor is going to see black, which is the outer tape, the black tape. And if I do that, the LED will come on. That's still at minus 10,000 RPM, but this one's at positive 10,000 RPM. So as it says here, it says analog B speed is equal to 255 and rotate. These are rotating, and the LED is high. So you can see the LED is high. That's just an indicator to show that's rotating, and motor B is set back to 255. So they're both at 10,000, but one is minus and one is plus. So it's rotating. And now once it stops seeing the black tape, it's still going for 500 milliseconds, and then you see the LED turning off there, and you see the top motor A is still at minus 10,000 RPM, and the bottom motor B is back to 7,500 RPM. So it's back to searching. So this can just happen repeatedly. It's just going to continuously search the area and keep searching and rotating. Once it sees the black tape, it's going to rotate. That's just going to happen over and over again. So we can see here, it's going to be driving along in this wide turn radius, and eventually it's going to see the object. So the object is going to go to below 30 centimeters, and now you can see both the motors are in minus 10,000, so it's going bang on straight. So it's in the attack because the motor B is set back to 255. So both of the motors are 255, and you can see here the motors are going forward. This is the motor A1 and motor B1 are going high, which is forward. So now we can see we're in state is equal to 1. So we're in attack right now. So now it's going to be it's basically pushing the it's pushing the object out of the arena at the moment. It's just going straight, pushing the object. Eventually it's going to see the edge of the arena. So I'm going to flick this to 1, which is seeing the edge of the arena. And you can see now, once that happens, it's going to go state is equal to 2, and it's going to stop, which it's not. In theory, it should be. Sorry, let me restart this. So it's going to go below 30. And let's see, there we go. So it's at 0. Both of them are at 0 RPM. So, and then it's going to be waiting 10,000 milliseconds, and it's going to rotate again. It's going to stop. So that's my circuit now. I'm going to be building this in the real circuit, and I'm going to demonstrate it in the blog just a bit below this video.